Hi, my name is Mohammad Ishtiaq and I am the presenter of paper depression detection on social platforms using machine learning techniques. First of all, I would like to introduce the authors. I'm Mohammad Ishtiaq from University of Engineering and Technology, Texla, Pakistan. Then Kainat Bibi, she is from Department of Computer Science, IBICA campus, Pakistan. Mahmoon Anwar from University of Engineering and Technology, Texla, Pakistan. Rashid Amin from University of Engineering and Technology, Texla, Pakistan, and Rahul Nijavan from Department of Computer Science and Engineering, University of Petroleum and Energy Studies, Dehradun, Uttarakhand. So, the outline of today's presentation is first of all, we would move to abstract, then problem statement, then related work, research methodologies, result, and at the end, we will discuss comparison with different data set and then we will conclude. So, abstract. Depression is the fourth major disease in the first world countries. Early detection is the key point, as if the depression is detected at the early stages, it would cause a very low impact. Otherwise, the issue becomes major, and then it will cause a lot of damage to a person's health, mental health, financial health, or moral health. Then the goal of this study is to explore machine learning to accurately identify depressive symptoms in the social media users. Our study seeks to highlight a machine learning classifier that effectively detects depression in user of social media. 5 machine learning classifiers are used: SVM, naive Bayes, KNN, decision tree, and random forest. The result shows that best machine learning classifier is 76% on Reddit and 78% on Twitter. The problem statement. According to the World Health Organization, depression is the most prevalent mental disorder which affects more than 300 million people worldwide. Depression is also the leading cause of more than 2/3 of suicides every year. However, due to self-denial among some patients and poor recognition of issue in many places, depression can remain undiagnosed or untreated. The lack of diagnosis and treatment can further aggravate the condition. The number of depression victims is increasing day by day. The timely detection of depression is mandatory to save people from devastating effects. One of the best way to detect depressed people is from social sites where they post the context to explain their feelings. There is a room for performance improvement as the existing studies employ limited phrases, sentence, and blog post with results in low accuracy. Hence, there is a need to develop a more accurate model by using ML techniques. Now we are moving toward related work. In related work, TF, IDF, and CNN detect depression with an F1 score of 0.67 and 0.37. And the TF-IDF with a morphological set achieves 63% F1 score. Bigram has an F1 score of 58%. Feature extraction was also used to sort a number of keywords, words, and phrases into the text, which significantly increased the complexity. The random forest model predicted accuracy with 62.64%. The author Tripathi used a hybrid ML algorithm, SVM, to select the feature from the trained data. Chaudhary ETL gathered feedback from hundreds of Twitter users who had already been diagnosed with clinical depressed via crowdsourcing. So this is our research methodology. We are using social media platform Twitter and Reddit. We are basically scraping data. Then we are performing pre-processing on that. For pre-processing, we are firstly use tokenization on the data set. Then we remove stop words, then stemming, and at the end we apply normalization on the data. Then after pre-process tweets and subreddits, we are applying feature extractor, which are TF, IDF feature vectors. Then for depression classification, we are using 5 classifiers, which are SVM, KNN, naive Bayes, random forest, and decision tree. After that, we are basically comparing the results and then we predict accurate model. Data, materials, and method. In data material, we are using basically tokenization, then we are cleaning the data, then we applying stemming and normalization. We are using useless data like here shown in the figure. For feature extraction, we are using TF-IDF, Ngram and word2vec. Here is an example, like if there's a sentence, I am getting mad, we are basically tokenizing all these. I am getting mad, then I am getting mad, I am getting mad, and then we are applying weights on that. For text classification techniques, we are using SVM, naive Bayes, KNN, random forest and decision tree. Experiment results. Results of applied classifier on Reddit dataset, we get accuracy 76% on SVM, precision 75%, recall 74%, and F1 75%. For naive Bayes, accuracy 61, precision 62, recall 66, F1 64. For KNN, accuracy 65, precision 65, recall 69, F1 67. For decision tree, accuracy 61, precision 63, recall 61, F1 64. For random forest, accuracy 73, precision 71, recall 82, and F1 76. Results of applied classifier on Twitter dataset. On Twitter, using SVM, we get accuracy 78, precision 69, recall 62, and F1 65%. For naive Bayes, accuracy is 56%, precision 65, recall 80, F1 60%. For KNN, we get accuracy 65, precision 76, recall 50, F1 56. For decision tree, accuracy is 73%, precision 64, recall 62, and F1 63. For random forest, accuracy is 75%, precision 69, recall 63, and F1 66%. Comparison with different dataset. Here is the data of different authors. They apply also same methodologies, and they get their results. Here is firstly author of paper 31, Chen Wong. Feature which he used is stylometric feature. Dataset which were used was Twitter ERIS 2017. ML classifier which he used was SVM. Accuracy was 70%. Recall is 70.18%. For paper 24, feature which he used is TF-IDF and bag of word. Dataset was Twitter. Classifier which he used is SVM. Here he get accuracy 66 and recall 37% and precision 61%. Author of paper 12, Stankiewicz and Maxim. They use TF-IDF, bigram, embedding stylometric and morphology features. Dataset which he used is Reddit, ERIS 17 and 18. Classifier which they used were SVM and random forest, and accuracy which they gain is 63 and 58%, recall 63.63% and 58.71% respectively, and precision was 63% and 53%, and F1 score is 57 and 54%. Author of paper 33, they use LIWC sentiment analysis. Dataset they use was of 2 million tweets, 476 users. Machine classifier they use were SVM and random forest. Accuracy they get is 70% and 74%. Recall is 70.78% and 74.44%. Precision they get is 63%. And our proposed model. In our proposed model, we use TF-IDF, Ngram, and word2vec features. Dataset which we are using are Twitter and Reddit. Classifier which is the best. I am just posting results of that, which is SVM. Accuracy is 78% and 76%. Recall is 62 and 74%. Precision is 69 and 75%. And F1 score is 65% and 75%. So conclusion and future work. So from the above presentation, we come to know that we employ dataset from Twitter and Reddit. We utilize pre-processing models, methods,